going to try to graph y is equal to negative 3 cosine of negative 2x plus pi halves. So, Will, this is the first thing I want to give you is we're looking at it in this form. Y is equal to a, right? Cosine omega x minus alpha. Do it again, minus alpha. Sometimes we'll, Brandon, we'll put a k out there. Can you see that on the board okay? Okay. Sometimes we'll put a k out there if there's a vertical shift, and I guess in this case there's no vertical shift. So first thing I'm going to do is it asks us for the amplitude. So what's the amplitude? That was pretty easy, right? And the period? The period, remember, the period is equal to 2 pi over omega, absolute omega, and the absolute value of negative 2 is just 2. So whoever said that is right. The period is pi, isn't it? Now, this is something that's a little bit different than the way we've talked about it. And the book likes to show it this way, so I'm going to show you this trick. It's also a trap a little bit, but let's try it out. That they say the phase shift is equal to the opposite of alpha over omega. And then they just take these two, they take the alpha and omega values, so they take pi halves is omega, isn't it? So the opposite of pi halves, up here, Brandon, the opposite of pi halves is negative pi halves. Is that all right? Over omega, and omega in this case is negative 2, so over negative 2. A negative over a negative is positive, so hopefully you can see that in this case that's what happened. This is a complex fraction, Allie, so this is like that, isn't it? So we'll take this thing, multiply it by its reciprocal, so we'll have pi halves times what? Good job. Times 1/2 is pi fourths. Pi fourths. So pi fourths. Now I'm going to show you this way because when I did it the way I showed you the other day, in this case, it gives you an interval to the left-hand side of 0. So it's kind of weird looking. Do you want to see that, or do you want to do it this way? Do you want to try it this way? All we're going to do, Brandon, to find out what the endpoint is to take the phase shift plus 2 pi over omega. What's 2 pi over omega? No, I mean, what does it stand for? It's the period, isn't it? So we take the phase, if we take the phase shift plus 2 pi over omega, we get the right-hand side. We get the right-hand boundary. Do you see that? So our phase shift was pi fourths plus pi, Danny, right? Plus pi, but I'm going to take pi, if you don't mind, I'm going to make it 4 pi over 4. Why would I do that? It's as obvious as it looks. What's the reason I did that? Kendall? Yeah, just for common denominator so I can see it better. And I'll get 5 pi fourths. Now here's another question. Mr. Murray, is this curve reflected, yes or no? Well, is it yes or no?
Yes,
How come?
because the negative 3 cosine reflects it.
This does right. This reflects it, right? What's the effect of this as far as reflecting it? Nothing, because this is right, and we remember that cosine of negative theta is the same as cosine of theta. And that was the mistake I had made on that other graph. Remember the sine curve? In the case of sine, it would have in this case reflected it and reflected it back. But because it's cosine, it doesn't do that. Is that clear? Okay, good. So this is what I'm going to do. I'm going to start graphing this a little bit. So here's the function. This thing is reflected, right? Mr. Murray, you said it is reflected, right? So I agree. I think I agree with you. I think it is reflected. So I'm going to make it this way or this way. Exactly. So I'm going to make it like this. I'm just looking at this one particular section. Now, just to be clear, because this is what freaks people out, they're like, where's the rest of the curve? The rest of the curve is here. It does exist. I'm just not following it. I don't care that much about it. I'm just trying to get a general idea of what this thing is doing. So I'm trying to, my phase shift. So what is this point right here? And what is this point right here? Yep. Allie? This is what? It's negative. Oh, I see why she said negative pi fourths. But I didn't do it that way. This is what? This is just pi fourths. And what is it? Negative 3. This is 5 pi fourths negative 3. And what's this value right here? What's this value right here? How do we find this? What's the relationship between these 3 points? The top one is the midpoint, so we're going to use midpoint theorem, right? And midpoint theorem says we take x sub 1 or x sub 2, however you want to do it, plus x sub 2 divided by 2. That's all we're doing here. So I'm taking 5 pi fourths plus what, Allie? Yeah, good job. Plus pi fourths all over 2, which gives us 3 pi halves. Everybody see what I did there? It was 6 pi fourths, so I simplified a little bit. Is that okay? And then, Allie, you see the complex fraction right here? So this is going to be equal to 3 pi fourths. So it's 3 pi fourths, comma what? Comma 3. Is that all right? Ellie, if I had done it doing this other way, if I had done it using this other way to find an interval of a phase shift, look what would have happened. I want to show you this algebra because it's really good algebra. And I know we're still... You know what? Let's do this. Not that. Let's do this. Let's do this.